Question number 10 says, a patient weighing 110 pounds has Dubutrex solution of 500 mg and 250 ml ordered to titrate between 3 and 10 mcg per kilogram per minute. After many adjustments, the rate is stabilized at 12 milliliters per hour. Find the mcg per minute range, find the range in mLs per hour, and also find the stabilizing dosage in mcg per minute. So there's a lot of information in this question. I'm going to start with the weight. So 110 divided by 2.2, we get 50 kilograms. So now I want to set up the 50 kilograms in a proportion with the 3 to 10 micrograms per kilogram. So I'm matching the kilograms. So I want to take 50 times 3 and then 50 times 10. We get 150 to 500 mcg per minute. So that is the range in mcg per minute for a patient of that weight. So now they want us to convert this rate into milliliters per hour. So I need to set up a proportion with my answer and the solution strength. And there's two things I need to do. I need to convert this to micrograms. So 500,000 micrograms. And I need to multiply this range by 60 because it's per minute and we need it to be per hour. So 250 times 150 times 60 divided by 500,000, and we get 4.5 to 250 times 500 times 60 divided by 500,000, 215. But they want us to round this to the nearest whole number. So this will be 5 to 15 mLs per hour. So what that means is that we start the machine at 5 mLs per hour, and if that doesn't work, we bump it up to 6. If that doesn't work, we bump it up to 7, and so on. And this one actually works at 12. So we know that our answer is probably right here because 12 lies between 5 and 15. And this is also where we're going to start the second half of the problem. So the backwards direction, we're starting out with the 12 mLs per hour, and we're using that in a proportion with the solution strength. So 12 times 500 divided by 250, and we get 24 milligrams per hour. But our final answer needs to be in mcg per minute. So we have two things we need to do. We need to convert. So I need to move the decimal place over 3 places. And then I need to divide by 60. And we get 400. And we know that this answer is most likely correct because this lies within this range. So again, there's always these checks that we can do. The stabilizing dosage, the 12 mLs per hour, this lies within this range. And then the stabilizing dosage in 400 mcg per minute, that lies within this range. And we used our solution strength twice.